So we just talked about nuclear fission. Now we're going to talk about nuclear fusion. Fission is when an atom splits into smaller ones. And fusion, as the name suggests, putting together, is the combination of two lighter nuclei to form a heavier one. Both fission and fusion are highly exothermic because the daughter nuclides that are formed have greater binding energy per nucleon. And the binding energy is, higher binding energy is more stable because it's, yeah. So fusion is the energy source of the stars, including our sun, and it's the basis of the hydrogen bomb, which is different than an atomic bomb. So the hydrogen bomb is up to 1,000 times more forceful than an atomic bomb. So the bombs that we dropped on Japan were atomic bombs. They did a tremendous amount of damage. Hydrogen bomb is up to 1,000 times more powerful. So in the atomic bomb, we have two isotopes of hydrogen that are combining to form a helium nuclide and a neutron. So this one's deuterium, hydrogen 2. So regular hydrogen, which is also called protium, has one proton. Deuterium has a mass number of 2 because it has a proton and a neutron. And tritium has a mass number of 3 because it has a proton and 3 neutrons. So the way a hydrogen bomb works is you get it going with a small fission bomb. And so that creates the extremely high temperatures that are needed for fusion to occur. This is an illustration of the fusion reaction. So we have tritium and deuterium fusing together, forming a helium nuclide and a neutron's given off. So this has been highly investigated as a power source. The energy density is much greater than fission, and we have fewer problematic products. So we don't have spent nuclear waste that we have to store or dispose of, and so that's really awesome. But the problem, the big problem is no material can withstand the extreme temperatures at which fusion occurs. So anything that you would try to contain this in would just melt or vaporize at the high temperatures that occur. So different things have been tried, and they can work, they're just not economically feasible, right? So this is a tokamak fusion reactor, and this is using magnetic fields to contain the fusing nuclei. Because there's no material, no solid material that can hold this, but we could use a magnetic field to contain it. Any questions? So I think, we all know that the sun is very hot, right? Extremely hot, right? And this nuclear fusion is occurring in the sun and other stars, and that's where that energy comes from. But we've not been able to do this practically on Earth because it requires more energy to contain, and what you get out of it, it's not practical yet. But hopefully someday in the future.